Hello everyone, and welcome to today's webinar, Avoid Production Pitfalls Through Manufacturing-Aware Generative Design. My name is Maria Ma, the Marketing Campaign Coordinator for Engineering.com, and I'm happy to welcome our speakers for today. We have Jason Lichtman, Senior Technical Specialist for Design and Manufacturing at Autodesk. Jason is a seasoned product design engineering professional who has 15 years of experience taking ideas and turning them into industry-leading mass production products for well-known brands. Also with us is Greg Paulson, Director of Application Engineering for Xometry. Greg works directly with customers on special case projects that require attention on material selection, design for manufacturing, or technical engineering resources. Now, before we get started, we just want to cover a few housekeeping items. Today's webinar will be recorded, then available for on-demand replay on engineering.com. For attending this full live session, you'll receive your PDH certificate within 48 hours. And if you have any questions, please submit directly in your webinar interface, and we'll try to address all questions during Q&A. Now, we'd like to kick things off with a couple of poll questions. Please let us know, which manufacturing method will you most likely use in the future? 3D printing / additive manufacturing, milling and or turning, sheet metal, injection molding, or other. We'll give you a moment to respond. So here are the results. At 36%, we have 3D printing / additive manufacturing, 29% selected milling and or turning, and tied at 14% selected sheet metal or other. Thanks so much for that. And we're going to launch one more. Please let us know, what is your current or primary CAD software? Fusion 360, Inventor, SolidWorks, Creo, CATIA, NX, or Onshape, or other. We'll give you a moment to respond. And here are the results. 36% selected Creo, CATIA, NX, or Onshape, tied at 29% selected SolidWorks or other, and 7% selected Fusion 360. Thank you for everyone who participated. And now without further ado, I'll pass it over to our first presenter. Jason, over to you.
Thank you so much, Maria. It is a pleasure to be here with you today. Today, we're going to be talking about avoiding production pitfalls using manufacturing-aware generative design. We have a packed agenda, so let's actually go through that agenda together. We're going to tell you a little bit about ourselves, as we're going to be talking quite a bit today, so we want to have you get to know us. We're going to give you an intro to Autodesk and to Xometry. Perhaps you're only familiar with one of those two companies. We want you to be familiar with both. Then we're going to hand it over to Greg. Greg is going to talk all about what DFM is and what that acronym actually stands for and why it's important. And then I'm going to take over. We're going to talk a little bit about generative design, how it actually works, and we're going to cover things like how does it create manufacturable geometry automatically, what manufacturing techniques or technologies does it solve for you out of the box, and how you can influence the shape of the part by adjusting the manufacturing inputs. Then we're going to go and talk a little bit more about Xometry and how you can use the Xometry for Fusion 360 app to get DFM or design for manufacturing feedback, as well as instant quotations for third-party manufacturing. Finally, we're going to talk about how you can modify a generative design result for alternative manufacturing methods. Now, that is a packed agenda, so we're going to move pretty quickly. Don't forget, of course, that this is going to be recorded, and you can always slow down or speed us up if you prefer us to go faster. So with that, I'll tell you a little bit about myself. My name is Jason Lichtman, and I'm a Senior Technical Specialist for Design and Manufacturing at Autodesk. I focus exclusively on Fusion 360, and my job is to meet with customers and to learn about their workflows, learn about their needs, and based on all of that, show them how Fusion 360 can change their workflows for the better. I come from a background in mechanical engineering, both in my bachelor's and master's degrees, and I spent well over 10 years in industry designing consumer products. I talk about how it's about taking ideas, turning them into 3D models, turning those 3D models into prototypes you can hold in those hands of yours, and finally, getting to mass production. I have quite a few specialties within industry, but they include design for molded parts, 3D printing, 3D scanning, reverse engineering, design for manufacturing, our topic for today, and of course, generative design as well. But I am joined today with a co-host, Greg Paulson from Xometry. I would love it if you could introduce yourself to the audience as well.
Yeah, absolutely. And thanks so much, Jason. Again, it's always a pleasure to be presenting with you and with Autodesk and talking about this technology and how technology is kind of enabling better design and manufacturing. I spent the last 14 years working in advanced manufacturing, whether working for product development or here at Xometry, where we make parts a reality in multiple manufacturing technologies. And I've always had kind of a very interesting role where I've connected with the mechanical engineers, the electrical engineers, the manufacturing engineers, and I've kind of seen all those worlds combined, being both a buyer and supplier myself. At Xometry, as a director of application engineering, I take that role and I work both internally as well as externally with our customers, almost somewhat consultative. Whether it is reviewing a design for manufacturability, which is a big topic today, or even that help me choose question. So what process should I choose at this point in my product development, and why should I choose it? And because if you look behind me here, I live in materials and testing them and breaking them. I take my experience and I try to build that into content here at Xometry as well. Very excited to talk today.
Perfect. Well, it's my pleasure to co-host with you as well. So let's give you each an intro to our companies, right? We're going to talk about Autodesk and Xometry. You might only be familiar with one or perhaps neither of our companies. So who is Autodesk? Autodesk is known as the AutoCAD company, but we're a whole lot more than that. The reality is that we're in 3 different sectors: architecture, engineering, and construction. Think design software to take an idea and turn it into a real building, a real tunnel, or a real bridge. We have a variety of different softwares for that purpose. We're also in media and entertainment. Think of the software that enables companies to make animated movies like Toy Story or Ice Age. And we are also, of course, within that media and entertainment division, also doing graphic motion effects as well. So think of the graphics in the background of Wonder Woman as an example. But I'm in the design and manufacturing sector. And the design and manufacturing sector is all about taking ideas and turning them into real products, physical products, whether they're simple or complex, whether they're individual products, equipment, or even systems. Again, we have a variety of different products within that category, but I represent Fusion 360. So what is Fusion 360? Fusion 360 is a platform. It's CAD or computer-aided design, it's computer-aided engineering or CAE, and it's computer-aided manufacturing or CAM. It can be used for anyone and by anyone, starting with industrial design to mechanical engineering, electronics engineering, manufacturing, and even production as well. Again, Fusion 360 is intended to be the platform so that everyone in your team working together can help design and then manufacture that product. Fusion 360 is cloud connected, and that enables you to have automatic file storage and versioning, as well as easy collaboration amongst your team, both internally and externally as well. Fusion 360 does a lot of individual things, but the most important thing to note is that it's not about any one of those things, it's about being able to do all of those things under one platform. Today, we are going to be focusing specifically on generative design, and it is my pleasure to represent the Autodesk side of things. But we also have Greg from Xometry. So with that, let's hear a little bit about who Xometry is. And with that, we have a quick video to play for you. It's just a moment while I turn that on.
What if you could access the world's manufacturing capacity with a few clicks? What would you build? Xometry puts manufacturing at your fingertips. Get instant online quotes on 3D printing and CNC machining. And access thousands of manufacturers worldwide. With Xometry Manufacturing on Demand, it's your time to build. Visit Xometry.com today.
Short and sweet. Yeah, so that's that's a little preview of what Xometry does. And what we are is, we are a global manufacturing marketplace. And I always like to tell our customers, like, what's in it for me? I'm like, we make a ton of parts. We can make parts on demand for you. And we solve a lot of these traditional procurement problems that you may have. You're trying to figure out who to source with, who's going to give you the best costs, all that. We actually use a single platform. We use AI and machine learning to give you pricing as well as feedback on your parts. And even when you buy, you're actually able to, we're actually doing the whole supply chain for you. So we're connecting your work almost as Uber connects drivers through its platform. We're connecting work with manufacturers that do that type of work really well, whether it's a sheet metal part, a CNC part, injection molded, or one of the multiple 3D printing processes that we offer. But we're a one-stop shop for manufacturing. And why it's really exciting, when we work with Autodesk is because Autodesk has the output of the CAD file. So our instant quoting engine takes that 3D model, it's a secure file upload, and it'll interpret and give you that pricing. And this is a free tool to use. And we're even going to show later on that we have add-ins. So add-ins for things like Fusion 360, Inventor, and SolidWorks. So you actually have access to some of these quoting tools on demand directly in the CAD instance. But what it really comes down to it, we make parts, and for my life, it's also seen a lot of parts from a lot of different industries, whether that's AM, whether that's subtractive, like 3, 4, 5 axis machining, sheet metal brake bending, and even casting processes. So whether it is that low volume production or low volume prototype need to full production needs, we're one place, and we're happy to work in parallel on multiple projects.
Excellent. Next topic we're going to talk about today is going to be, what is DFM and why is it important? So Greg, can you tell us, what is that DFM acronym actually stand for, and why should I care about it?
Yeah, absolutely. So what do I do? What do I do all day is your real question here. But DFM stands for Design for Manufacturing, or Design for Manufacturability. This is where the rubber hits the road when it comes to your CAD intent, and that intent for it to actually be something physical, like a physically produced product. What DFM is the consideration of the manufacturing process and material within your design effort, because different manufacturing processes have different rules just by the way they actually fabricate, the way a mold tool works, opens and closes, the way that a CNC tool spins and creates features. When you're adding that design intent during the process, what you're really doing is also reducing costs, things that can hold up the job. So like production risks, you're reducing delays. So for example, if you order a CNC part and you have some DFM features that we cannot produce with that process, we may need to put that work on hold, ask you a few questions for some exceptions, adding a radii here, for example, but that may cost you some days for that. So being able to do that somehow, some way, while you're in the design process will save you a whole lot of conversations and headaches on the tail end when it comes to actually producing that part in your end use process. And DFM, it just helps manage those expectations too. What I design is what I'm receiving. And that's a really big thing when it comes to custom manufacturing, for sure.
That makes perfect sense. So I think what you're saying, Greg, is don't just design anything you want and then expect somebody at the very end to modify it so it's manufacturable. Ideally, you're actually designing it to be manufacturable from the very beginning.
Correct. Like you usually are starting to design with some of that intent in mind. And one of the things I kind of love is that when you're prototyping, a lot of times you're using something like 3D printing, additive manufacturing. And the good news is that a lot of DFM tips for some of these different, more production grade processes like machining or injection molding tend to go hand in hand with some of their surrogates. Like, so for example, FDM, that filament-based 3D printing, goes really well with these rules that you see in front of us right now, like DFM examples for CNC, and it's a great surrogate when you're prototyping through. So I'm not going to read through all the text on these examples, but I do want to show some of these most common things that we see at Xometry that are DFM issues that we may flag post-order, or we may catch pre-order and ask for a slight modification. There's really two reasons why, and it's all around how this machine works. I'm CNC machining, I'm holding my part still and stable, and I'm spinning a tool to go through and either drill or cut and create the features of my part. There's a few things that happen. First off, that tool's spinning, so that cross profile of the tool is always a circle. That means that if I'm trying to cut a square corner, I can't. I'm always going to have a round there. So that middle one, for example, rounding internal corners, super common thing that we see as a DFM kind of stop. It usually is adding a 30-second radii or something like that to mitigate that issue. The other thing is I have a metal tool, I have a metal or plastic part, I'm holding them still, but as things get thinner or as things get deeper or longer, stuff can tend to vibrate because I'm moving super fast with that tool. So thin walls are an issue with DFM and CNC because it may vibrate that wall and create a chatter feature or deformation on the part as it's being produced. And the same thing with drilling. If the tool gets too long to access that feature, it could also vibrate and cause a similar issue. So, when you think about that, this is how the process dictates parts need to be built, and having those considerations really help out. Let's go to like examples. And let's go on the opposite. So what if I'm not cutting? What if I'm growing? And again, we're just showing these examples because it helps get you in this mindset of I'm not cutting a part when I'm 3D printing. I'm actually depositing material and fusing it together layer by layer. And that material, it's finite. It's not, it's not like I'm shaving down to a razor edge on a piece of metal that already exists. I'm compiling another filament or that powder. That means things have a minimum thickness to it. Thin walls are typically the largest rejection criteria that we see on 3D printing. We may be able to move to a more sensitive process for thin walls, or just thickening up will take you a long way. Sometimes the programs that actually program 3D printers will look at a thin wall and say, you know what, I can't do it. It won't exist. And it doesn't even actually make it to the machine. That's how sensitive sometimes these issues are. Same thing with thin gaps where there's nuances in the process that may actually fill or fuse or create a issue where material's trapped and cannot be escaped from that. So we have design rules against that. And then ultimately, unlike CNC where I'm fixturing a part and holding in place with a set fixture, I need to kind of build that fixturing, the holding situation of my parts in most 3D printing processes while I'm actually making that part itself. And so that's support structure. This is a sacrificial structure that needs to get removed. When I remove that, it does leave little nubs and possibly some surface defects, and it can affect geometries. So minimizing that is a great DFM tip to help create a more consistent expectation.
So Greg, you're talking a lot about these rules that you need to follow.
Yeah.
How hard are those rules, so to speak? Like, can you break them? Or is it really just about knowing what the rules are so you know when you should break those rules?
Well, let's segue into the next slide because I think we're in we're right in the same world there. It is a slide scale, right? It's a continuum. The reason why is that, yes, I can create specialized tooling and I can procure it. So a lot of times I get a question of, can you make it? And almost like, unless it's something that's impossible to access with any tool that exists, the answer is yes. The real question is, should I make it or should I incorporate that in my design? And that also plays with quantities a lot of time. That image on the right there is two configurations of the same design. The initial design was a unibody feature. So you see this kind of L-shaped design. Unfortunately, I don't have the picture of the front of it, but I wanted a picture of like the physical model just so you could see it here. But yeah, what you're pointing out is a pocket. In order to cut that pocket with a tool, I need to go down the entire length of that wall with clearance on a tool, and it creates a very specialized tool need, and also incorporates something that incorporates risk of chatter, so like kind of rough vibrations across that surface finish. What we are actually looking at this is a production piece. This actually is used in packaging sorting. So like at USPS, FedEx mailing facilities, this is holding this sensor scanner that is above conveyor belts as packages are moving high speed. So it has some production volumes to it. We actually found that it was better to manufacture and ultimately cheaper to manufacture by disjoining those features, creating two separate parts. So even though I'm making two parts, it actually mitigates risk on the production line. I can make it faster. I save about $400 a set on producing these. There's massive value added with the addition of kind of that design for manufacturing aspect, especially when you think about production. It's more and more sensitive there.
That makes perfect sense. I think this is a good example of reworking an existing part to be manufacturable. So
Correct.
redesigning it for manufacturing. But I think we could both agree that if they kept DFM in mind from the very beginning, they would end up with the final result much faster and would have saved quite a bit of money as well.
Absolutely, and this is something analogous. I always talk about how as technology evolves. This is kind of like going from a typewriter where you could get away with erasing the last letter. I'm not sure if anybody remembers that, but you can with a typewriter. And then eventually you move to a word processor where you start getting like squiggly underlines, right? And we're kind of in that world where you're starting to see the squiggly underlines. But I think what we're about to talk about is this next thing where as I'm typing, just stuff corrects. It just happens, and I'm excited to learn more about what generative does for DFM. Yeah,
Autocorrect at its finest, so to speak.
it's autocorrect. Yeah.
Yeah, very cool. Now, all these rules you were talking about, I have the feeling that if I'm designing something manually, I want to keep them in mind. So what's the best resource to find all of those rules?
Yep. Oh yeah, so what part of my life is trying to take this tribal knowledge of making and breaking parts throughout my career, as well as the knowledge of all of our experts in manufacturing and Xometry, and just for national standards, and putting them into documents and videos and resources through Xometry. So xometry.com/resources is a gateway to a bunch of free tools, including design guides for all these features. So if you want to dive deep into the guides and kind of the why behind it, so like why do I need these type of features? How should I do it? What are the best practices? Definitely check out our free design guides, as well as we have some wonderful webinars that are recorded webinars and short videos explaining different processes as well. But definitely recommend xometry.com/resources to get looking.
Excellent. Cool. So we talked quite a bit about what DFM is and why it's important, and some resources to learn more about DFM for your particular manufacturing process. Now we're going to jump into a slightly different topic. We're going to talk about generative design and how generative design's manufacturing awareness is going to allow you to design your parts faster and, of course, design better parts. So the first step is to understand what generative design actually is. And generative design is a design exploration technology. It simultaneously generates multiple CAD-ready solutions based on product performance requirements and real-world manufacturing constraints. The emphasis here today is on the real-world manufacturing constraints. So you're going to tell generative design how you are interested in manufacturing this part, or the multiple ways you're considering manufacturing the part, and it's going to give you different solutions to the problem for each of those manufacturing methods so that you can compare and contrast the pros and the cons of each of those different options you have to consider, the trade-off, so to speak. And having those options early on is going to help you considerably, and you'll see why in just a moment. The why really stems from the goal of engineering as a whole. I'm a mechanical engineer by background, as I mentioned earlier, and I've worked in industry, so I've seen this firsthand, that the goal of engineering is to strike the right balance between the performance and the cost for a given product. And when we're doing this exercise, so to speak, the performance can mean many different things. It could be trying to make the part as small as possible, as lightweight as possible, as stiff as possible. But really what we're trying to do is to try to find that balance between whatever we're considering high performance and the cost. Sometimes a performance gain is just not worth it because the cost jumps so dramatically. And typically we're doing all of this under a tremendous amount of pressure. We're limited in time and energy that we can spend on any design problem to really fully explore all the options that are available to us. And when I say limited in time and energy, I also mean limited in resources, limited in money that you can actually spend towards solving that problem.
Are you saying that you have overhead?
Yes, we have overhead and budget, and sometimes our corporate card has a really low limit also, Greg.
Yeah.
You know, we're always trying to do more with less, so to speak. Have you found that in your world as well?
Absolutely. I mean, especially when I was working in product development, you had direct labor, right? Yeah, and there's a what you call LOE, or level of effort against a program, which you're hoping to stay in budget because that's what was budgeted when the bid was set out for the customer. And if you can do more digitally, quicker, it does bring you to a larger advantage when you are working on the results side of things. It gives you much more leverage, and often you get better results. And we see that with iterative rapid prototyping of products, but being able to kind of iterate on the digital side is just as important, if not more.
I agree. Let's dive into this balance that we're talking about here. I think that this might end up being helpful to everyone. So here's an example, right? Let's say Greg and I, we work for Toyota and we happen to like cars. So we're going to use Toyota as an example, and we're designing the next vehicle for Toyota. The next vehicle might be intended to be low cost and therefore low performance, like this Toyota Yaris you see on the bottom left. It might actually be that we're designing the next generation of race car, where it's high performance, and that's the most important thing, and as a result, we expect high cost. But Greg, what are the chances we're going to be lucky enough to work on a project that's so explicit in its goal, right? Typically, it's a little bit more gray area, would you agree?
Yeah, absolutely. Like you're given some requirements. The world they expect the world out of it, but you also have your constraints to work under. Yeah.
Exactly right. And so now you can start to see a couple of other models of Toyota vehicles come up. The Camry, the Avalon, the Prius, and the Corolla. And you'll notice that they're kind of more in the center of this particular curve. The balance between the performance and the cost becomes much more nuanced. And the difference in that balance is what makes each of these vehicles unique, so to speak, right? What makes them have its own market, so to speak, as well. And it's important to recognize that balance because ultimately that's what you're going to be doing as well in your product design. So this is again just an example of that in the vehicle world, but just you'll see many more examples of this coming up as well. And again, we love vehicles, so here's one more. So this is an example. This is an Autodesk customer, Lightning Motorcycles. They make the fastest electric motorcycle on the planet. And they use generative design to help them lightweight their motorcycle so that they can go even faster. We're going to focus on the rear swing arm of this particular motorcycle. You could see it in the upper right-hand image in blue, but what you want to see here is that they were able to evaluate the trade-offs, and the final part was actually cast. So while it's going to look like a 3D printed structure, keep in mind that you can very much manufacture these parts in traditional means, whether it looks like it initially or not. So with that, let's look at the typical product development process. So we try to get as many concepts as we can as early as we can, but again, we have limited time and resources, so we don't get that many. And then we start to evaluate them for the performance and the manufacturability. And if we have to rework that design, like the part that you saw, that two-piece construction that Greg showed earlier, you might have to restart some of this again, making delays to your process. But eventually you're going to end up with a final part. In this case, the rear swing arm of the original motorcycle. And while it looks like a good product, it actually looks like a great product from a traditional sense. With generative design, you could do even better. So here's what the generative design process will look like. You get multiple validated manufacturable options earlier. And the emphasis here is that they are pre-validated to be manufacturable. The design for manufacturing that Greg was talking about earlier and is so critical for you to be able to go from that idea straight into production, that's already been done by Autodesk. Using artificial intelligence, Autodesk is able to create multiple solutions for your problem that are based on that performance requirement that you give it and the real world manufacturing. And the result is that you can get to production much faster and yield a significantly better product. So on the right, you can see the final result. Again, this is a cast result, even though it very much looks like it should be for 3D printing. But the emphasis here is that not only are you able to get a better product, you're able to get it much faster. You have a significant productivity increase and you get to market much faster as a result. But if you do want to look and compare the products to each other, now you can see the traditional swing arm on the left and the new generatively designed swing arm on the right. And you can tell right off the bat, I don't need any scale to know that the one on the right is going to be lighter. Greg, would you agree on that?
Yeah, it's really just interesting because I think we were showing the slide earlier. We were talking, and I was like, one of the things that generative does is it creates solutions that are not intuitive. It's not the way that you traditionally think about manufacturing, and we even talked about that in CAD software. You know, you usually see a cut, extrude. You see linear motions of things, and generative it just looks at the purpose. You know, looks at what is your what is your purpose, what is your goal, like on that line, like you were showing. And in this case, this is definitely a lightweight, high value performance component, and this is the outcome of that.
That's exactly right. But again, the key is that you're going to get lots of solutions to the problem, not just this one. And you get to choose the right balance between those trade-offs. And as you're analyzing those different trade-offs and the different results, keep in mind that you can analyze them both qualitatively, like looking at them aesthetically, but you can also evaluate them quantitatively. So you get to see the weight versus the safety factor, the stresses versus the safety factor, the stresses versus the cost, and a whole lot more. You can even export your results from Fusion 360 to Excel if you'd like to do further statistical analysis as well. So the point here is that you get the best of both worlds. You get to compare it both aesthetically or qualitatively, and you also get to compare it quantitatively as well. It's cool stuff. So with that, let's actually show you what this looks like. I have a brief video that's going to explain this much better than I could do just talking. So give me just a moment while I queue up that video. Perfect. So again, we're looking at the rear swing arm of this particular motorcycle. And the items that you're seeing in green are what we call preserves. They are the connection points that this item or product is actually trying to connect. After all, a rear swing arm of a motorcycle has a purpose, just like Greg was talking about. And that purpose is to connect the main frame of the motorcycle to the rear wheel. These are the connecting points that are intended to be connected. And the green items, or the preserves, are the geometries that must be in the final result for it to function. But just as important as it is to know what must be in the result, it's also important to know what must not be in the final result. So we also have obstacles as well. I'm going to go and play the video again so you can see the obstacles too. So here you can see the obstacles being generated. The obstacles themselves can be the actual geometry of your product. So in this case, the wheels, the sprocket, the motor, the shock absorbers. You can simplify those geometries using generative design tools that are built right into the application. And you can also expand them to increase the gap, so to speak, between your parts. So you can make sure that you're going to get a nice fit. And it also helps not just for design for manufacturing, this also helps for design for assembly, or DFA, another acronym that Greg loves. So generative design allows you to specify where your part must be as well as where it can't be. And to be clear, for any of you out there that happen to be aware of shape topology optimization, generative design is very different than that. It works in a very different way. And the way that generative design works is able to add material just as much as it can remove material, but it adds perhaps a little material here to remove a whole lot of material there. And that's very important. It's not just taking a final result and chopping out holes, it's actually generating these designs from scratch. And it's doing that with manufacturing awareness so that you get those parts that are already ready for manufacturing. I'm gonna hit the play button again so you can see the rest of. So now it becomes somewhat of a standard FEA study, or finite element analysis. You provide the loads and the boundary conditions. You tell it what kind of manufacturing methods you are willing to explore, and it's going to generate not tens, but potentially hundreds of different results based on all of those inputs. You can filter those results based on a whole bunch of different criteria, qualitatively as well as quantitatively, and pinpoint which are your top 5 choices, or top 3, or even top 2 choices. But once you do, now you get to compare that balance that we talked about earlier, whether it's worth saving an extra 100 grams and doubling your price. Sometimes it is worth it. I mean, if you're designing the lightest motorcycle on the planet, then it might make sense. But if you're designing that Toyota Camry or Toyota Corolla or Avalon that we were talking about in that analogy earlier, then maybe it doesn't make sense to double the price, right? So it's really about analyzing what makes the most sense for your particular project. Once you analyze what is the best choice for your particular project, then you could go and start manufacturing it. Fusion 360 is a CAD, CAE, and CAM solution. So if you do have in-house CNC machines or additive machines, you can utilize Fusion 360 to control them, output G code for the 3D printer or for the CNC machine as well. But if you don't have all of that capability in-house, or maybe you do and you just don't have as much capability as you'd like, that is the perfect time to start including Xometry in the equation as well. So let's go back to our normal slide and let's talk about how you can incorporate Xometry into your process. So first, let's cover the workflow. All right, the workflow is define the problem, generate your results, explore the results, and of course, pick the best result for your application. When it comes to manufacturing, we have a lot of different manufacturing methods that are available. Additive manufacturing, which of course is going to give you more organic shapes. We have die casting. We also have quite a few options in the milling arena for 5-axis machining, 3-axis machining, 2.5-axis machining, which I think is my favorite of the bunch. I think, Greg, you might agree with that as well.
Yeah, we'll talk about why when we see the results. Yeah.
Exactly. And then lastly, of course, 2-axis cutting, which is for laser cutting, water jet cutting, or even plasma cutting. But of course, you could run this in a milling machine as well. It's really your choice. But if we're looking at examples, this is another great example of what we're talking about. This is a triple clamp for a motorcycle. You can see a common theme here. We love cars and motorcycles. In my opinion, it's anything that goes fast and is a little dangerous is fun to me. But here is an example from MJK Performance, and they design triple clamps that are aftermarket accessories for Harley Davidson motorcycles. And here you could see the comparison between different options for this triple clamp. The final one that they used was the 2.5-axis option. But if you compare the available options, you start to get a picture of what the manufacturing option actually does to the geometry. So you have a human design on the left, the 2.5-axis generative highlighted in green because that's the one they finally went with. And then you have the 3-axis CNC machining result and the additive result as well. And you can see the very distinct differences in geometries. What's common between all four results rather, are going to be those preserves, right? Those preserves must be in the final result, but how to connect the dots is what's different. And in all of these cases, those dots are connected in a way that is manufacturing aware, that is already designed for the manufacturing. The DFM is taken care of for you. And that to me is so important. And don't forget, it's not all about additive manufacturing, as important as additive happens to be today. It's also about very traditional manufacturing. And so this is the final part here, is made in 2.5-axis CNC machining. And when we first introduced this to the world, the very first comments we got were like this one here from Empowered One. No offense meant at all, but how on earth was this generatively designed? It looks like it's parametric or prismatic, basically like a human designed it. This is actually best compliment I could get.
Absolutely, and this is what excites me. I mean, I love the organic structures and what you're showing. For the motorcycle component, like they are, very powerful. But the trade-off is a lot of times cost, right? There's surfacing, there's milling, there's extra processes to it. But many people don't think about generative in the way that this picture is depicting it, where you're essentially creating a result that any machinist can look at this. And this is essentially a 3-axis mill with a couple other setups for those, like a slitting saw for the sides there and some other features. And you can do it on 5th axis too, and do it almost all in one op. But it is a very approachable, manufacturable design. So the costs are not going to be as driven as some of those organic shapes that are fully milled out. And if something you could use Xometry as some pricing for is to really see that difference, right? Like what the a surfacing requirement does to pricing versus something like this where you have vertical walls across the part.
Exactly right. And I'll note, this is optimized for weight savings, right? Trying to reduce the weight on that Harley Davidson so you could go faster or accelerate faster. And you're able to get the best of both worlds. You're able to get an optimized part from a weight perspective, and you're able to get there faster because not only is generative design generating the shapes for you, it's also making sure to keep manufacturing at the heart of how it's generating the geometry itself. Yeah, so let's start looking at how you can start to influence the shape, right? So If you start to use generative design and you're starting to like the results, but you want to be able to have more control over the shapes, how could you do that? And for me, I like to say it's all in the options. What you're seeing on the screen right now is the dialog box from Fusion 360 showing a highlight of each of the manufacturing options in particular. I have additive highlighted on the left, then I have die casting, then I have milling for 5-axis, milling for 3-axis, milling for 2.5-axis, and lastly, the 2-axis cutting. The options here are the key. So when we talked earlier about those design for manufacturing rules that you're going to be able to download from the Xometry website, those rules tell you keep to at least this for your minimum wall thickness, or keep to this or keep to that draft angle. And those rules are applied right here in the options. So if you're additively manufacturing and you want to reduce those supports that Greg was recommending you reduce earlier, you can reduce those supports by modifying the overhang angle. And if you want to make sure that you don't have any features that are too small, the minimum thickness is a great option to modify. If you wanted to make a part that's more blocky, all you have to do is change the minimum wall thickness. If you changed it from 2 millimeters to 20 millimeters, you're going to get a very different shape, right? And that makes perfect sense. The same thing is going to apply to all of the different manufacturing methods. So die casting, in addition to minimum thickness, is also going to ask you for maximum thickness and a minimum draft angle. When we talk about milling, it's going to ask you about the minimum tool diameter, the tool shoulder length, and the head diameter. But when we start talking about 3-axis, it's going to ask you what direction is that tool going to come from. And if you choose multiple directions, you're allowing multiple setups, because after all, it's a 3-axis machine. You have to take that part out of the machine, reorient it, put it back in to get each of those different access angles. And each time you do that, you're adding labor and cost. So you're able to drive those costs or keep to reducing those costs by manipulating these options. And by doing that, it's also influencing the shape. So if you want to have the most influence on the shape, change the actual manufacturing method. If you change it from 2.5-axis machining to additive, you're going to go from a much more blockier geometric shape to a much more organic shape.
Yeah.
But even within these manufacturing methods, you can tweak these options based on your needs.
It's what I love is and I think a future webinar, maybe we talk about die casting itself or just the ability to generate draft angles. The things that, I see a lot of stuff and, adding draft to a tooled process, a tool design in retrospect is a lot more difficult than, designing within, especially if you have more complex features on your part. And something we often see is adding those draft angles at the end, especially when you're moving up to a tooled process. So being able to essentially click and go with that is kind of amazing.
I agree. Yeah. Play with all of these options. I highly encourage you to play with them. Remember, though, that by adjusting these numbers, not only are you going to be able to make sure that it meets the demands of the equipment you're actually using and the tool library that you're actually using, but it can also influence the shape itself. And later on in this webinar, I will talk a little bit about how you can go beyond these manufacturing methods with some alternatives as well. So the next question becomes, how do you leverage Xometry for that DFM feedback and for quoting? And with that, we're going to jump live into Fusion 360 itself, and we're going to show you the brand new, newly updated Xometry app for Fusion 360.
V2.0, yeah, and this is, as Jason's opening up Fusion here, we released a Fusion 360 app, and so everything that I showed that you could do on Xometry's website by uploading a file, and that's something that is always available at xometry.com, we extended into different CAD platforms. Fusion 360 was the latest. We released that, gosh, how many months ago? It wasn't too long ago, but as soon as, when we released it, we had the vision of what this 2.0 project is in mind, more DFM. Also, for folks who are listening internationally, we now have 5 languages in this app and serves Xometry Europe as well, and being able to quote multiple parts. But this is live. You're in your CAD instance, and you're able to see and review pricing right there as you're designing.
Exactly right. So here is the final part, right, that MJK triple clamp. I've already run this through the Xometry app, but I'll show everyone how to actually do that in a moment. But just so you're aware, it's going to instantly tell you the pricing, the lead time, and also give you the DFM feedback right away. So while you can certainly download the DFM guidelines that were on the website that Greg mentioned earlier, and we highly encourage you to do that, you're able to get that feedback based on the geometry automatically. So in a part like this, I see the small gap check is firing off, no surprise. We have these slivers on each of these areas. That's where the clamping actually happens. Unfortunately, we can't get rid of those, right? But knowing that there is a small gap and that in order to manufacture it, it's going to increase the price is still helpful. Right?
Yeah, so this is to your point. Sometimes DFM is that's the difference between can we and should we. In this case, that slit is actually purposeful. I'm tightening a bolt against it to tighten against different shafts on your vehicle. So we have that there to help recommend, but it's not a showstopper.
Exactly right. And then we also have some internal corners that we might want to fix. It turns out 65 of them, and we could go back in and update the model and of course get updated pricing. And to me, what I love about the Xometry app, besides the 10% discount that you get by using the app within Fusion 360, besides that, what I love is that instantaneous feedback. Because when I was in industry, I used to have to send my part off to 3 different places or 3 different shops, wait a couple of days to see if they had any questions about the part, and then finally gave me feedback on the part, or maybe just gave me a quote. But with the Xometry app, I could get that quote instantly. And I could do so for a variety of different manufacturing methods. So if it turns out that I'm really looking for a looks like, fits like test, maybe I'm really going to go and send this to a 3D printer. I can change this to fused deposition modeling, change the material to maybe ABS or ASA, and then get a new estimate. And in the background, I believe, Greg, this is where the machine learning algorithm comes into play. Is that correct?
Yeah, so the pricing is the pricing is basically reviewing the geometry, creating a estimate based on market fair pricing. So parts like this on a competitive marketplace tend to be priced at this amount, and that's the pricing that you're going to see. Since this is working through the app, it's kind of doing a send receive right now. So that's what you're seeing on the creating estimate side as you're updating these features. What's really cool is you could actually see as you're designing, kind of do this spot check. You could do some modifications of your design, or in this case, when you're talking about generative results, take a look at your different generative results, see what that pricing is going to be. And even as you modify, there's actually a selection where you can kind of refresh the model and see how that price updates. I always like to think about it as like, pricing is part of your prototyping process now, or your product development process. Sometimes pricing comes at the tail end, or you start getting quotes when you're way down the line, but now pricing can just become part of your overall development process. And again, also, I know we're doing like a live demo here, so let's see if the creating estimate shows, but it should show.
It'll show. But for me, I love that live pricing because it means that I can make a change to my design, get the pricing, make another change, and see how that change influences the pricing itself. So if I'm debating whether or not it would be more cost effective to add a through hole or a tapped hole or this or that, I can actually make those changes, get the pricing, and then based on that, choose whatever makes the most sense for my particular product.
Yeah, and there we go. You just went from about $2,000 to $200 there. And this is, FDM 3D printing. You can even expedite that if you jump to Xometry site to 1 business day turn time. So there's a lot of options to work with. And I think the CNC machining turn time was on 10 business days. And all these help you get some upper level estimations, but you can really dive deep and specify when you jump to Xometry's coding site. And that's things like adding, threads and tapped holes. If you have different finishes for this, to say this is like a, blue anodized component. If you have a, tighter tolerances, want to add a print or drawing, that's where you'll go. And as Jason mentioned, we're really excited about the Fusion 360 app. We have a 10% running discount on products that you're actually jumping to Xometry site with through Fusion 360, and that's something that you'll see at checkout. So very good way to save costs as well.
Perfect. All right, so the next step, and I believe this is the last topic we're going to cover today, is how you can actually modify the results. And there are a variety of different reasons you might want to modify the results. They might be for aesthetic purposes or even for alternative manufacturing methods. And so let's look at how you could actually do that. So first, a couple of examples. Here you could see a wheelchair. This is an incredibly modern wheelchair by a company called Will. The orange piece in the middle is the current frame, or at least the previous frame. And with generative design, they were able to get it to the following. And it looks a lot lighter. It actually is a lot lighter, but then the aesthetics also become part of the form factor of the product itself. But if you look at the results that were initially from generative design versus the modifications, you'll see that the one on the left has a little bit of what I call whirlbly wobbles, and the one on the right is smooth, more uniform, and much more aesthetically pleasing. There are a lot of different ways to make modifications like this. You can modify the original data using the sculpt or form modeling in Fusion 360. The output of generative design is not always just an STL model. It can be a whole lot more than that. It can be a parametric design. So you can use the sculpt or form modeling to make changes to that model and sculpt it until you're happy with the aesthetics. You can also rebuild from scratch using a variety of different methods. Traditional solid modeling, traditional surface modeling, direct editing, or again, using the sculpt or form modeling. But you are not bound by just these options. There's a whole lot more as well. So how do you do all of this? Here's an example of a shelf bracket. From a side view, you can see it looks pretty unique, but if you start to analyze what's inside here, you'll see that the areas I'm highlighting in green are the dominant load paths. In yellow, these are the subdominant load paths, still important, but less important. And the areas in red are the recessive load paths. You could build them or you could ignore them. And using this information, you could rebuild this particular bracket in a variety of different ways. So on the left, you're seeing the untouched generative design results. Then, second from the left, you could see the modified results using sculpt modeling to make those modifications. Looks a lot cleaner, more aesthetically pleasing, and actually looks stronger, even though the one on the left is strong enough to meet the demands put in front of it. But you can also rebuild this from scratch using traditional solid modeling, or you can rebuild this from scratch for sheet metal. And the emphasis here is that sheet metal is not one of the manufacturing methods listed in the methods that are available. So keep in mind that you could always rebuild your design based on those load paths in a variety of different manufacturing methods. There are a lot of different options to choose from. And one example that Greg and I like to talk about is how there are even additive manufacturing processes like HP multi-jet fusion and SLS that tend to benefit from some of those requirements for injection molding. But die casting is one of the options from generative design. And die casting, if you set the minimum wall thickness and the maximum wall thickness to be somewhat close to each other, can yield results that are nearly nominal wall thickness, which are great for injection molding, also great for SLS 3D printing, also great for HP multi-jet fusion 3D printing. So just keep in mind that the manufacturing methods that are out there are incredibly useful for even more than the label might imply. And if you want to go even further than that, you can always use the techniques I showed just a moment ago to rebuild the model from scratch using any manufacturing method you can conceive of. If you have questions about anything that you saw today from the Autodesk side of things, you do have a method to reach out to us. Oh, wrong button. Let's try this. If you want to learn even more, you can reach out to the Autodesk Fusion 360 sales teams. We have phone numbers and email addresses available on the screen right now for you to be able to reach out to us. You can tell us about your business, about your needs and your application, and based on all of that, we can customize a demonstration to meet your specific use case. If you have questions on the Xometry side of things, and I imagine you might, Greg is a perfect resource. Greg, can you tell them how they can reach out to you?
Absolutely. So you can see like my signature there at the bottom. Always feel free to reach out, and I can make sure to get you connected with the right folks. We're always happy to kind of review a project, run through some designs, you know, that you've uploaded to our site, and we could you know go through that DFM check as well. But Xometry.com serves all of North America. So if you type in Xometry.com, that's where it'll take you. as the instant quoting engine, as well as those really good resources. Including under that resources tab, there actually is a link for the apps. So if you're looking to try out these apps, you click on those links, follow the type of CAD program that you're looking for, and you'll find a download link through there. The other thing to note is that we are a global company. So if you're European, Xometry.eu will serve all of Europe and has similar functions. So we really are here to serve manufacturing. We like making parts, and also please, ask us some questions. We see cross-industry manufacturing examples daily. A lot of us have seen tens of thousands of drawings at this point, and we have some insight on what works and where design changes are needed based on where you are in your product development process.
Perfect. A quick summary before we go to Q&A. We covered today what DFM is and why it's so important. We also covered what generative design is and how it works, how it can generate manufacturing aware parts and products for you based on the product performance requirements that you provide, the materials you select, and of course the manufacturing methods you are willing to manufacture in. You can analyze those results qualitatively and quantitatively. You can take those results and you can edit them, either for aesthetic purposes or for tweaking the manufacturability or for tweaking it for entirely new manufacturing processes. There are a lot of things you can do with generative design. It's all about getting started. We also gave you information on how to reach out to us, both at Autodesk and to Xometry. So if you do have any questions or concerns, please reach out to us. We are happy to help. And so with that, we are at Q&A. Maria, do we have some questions from the audience today?
Yes, we do. Awesome. Well, thank you, first of all, for that great presentation. And here's our first question. Consider a car's trailing arm generatively designed, as in the lightning swing arm. At some point, the lower chords of the trailing arm may be used as a jacking point. What loading scheme should be used to ensure no damage in such a case?
Great question. So it sounds like this particular viewer is already thinking about how they're going to use generative design for their business. I love that. It sounds like that application is going to require multiple load cases. We didn't talk about it earlier, but you don't have to be limited to one load case. Just to define, a load case can have multiple loads in it, but different load cases are for different loads that are not happening at the same exact time. So the trailing arm that you described could have one load case for the resting position, one load case for while it's under this type of load, and another load case under a different type of load. And it sounds like being jacked up would be one of those load cases.
Jacked up, yeah.
That's
actually a really interesting application. I really enjoy that question because I think we were talking earlier. I was like, that's my type of question too. Is there's in movement, right? And then there's I think sometimes when we design things, there's also in transport. In this case, it's when it has a second purpose. It's a dual function device, right? It's a structural piece as well as just the trailer component.
Exactly. Now I can't help you with the specific loads you should use because I don't know enough about your application, but I did mention earlier that if you'd like to reach out to Autodesk, we'd be happy to talk to you, learn a little bit more about your application, and help guide you along the way. So please reach out to the Autodesk sales team.
Perfect, thank you. Next question, how can we evaluate risk in generative design?
Ooh, interesting.
So that's this like engineering factor or factor of safety type stuff?
Yeah, I mean, there are a lot of different ways to apply risk. Safety factor is certainly one of them. And just to define for everyone, safety factor is how much load will it actually take relative to the expected load before the part breaks. So if, for example, you're designing a chair and you expect the maximum weight of a person to be 300 pounds, a safety factor of 1 means that if you have 301 pounds on that chair, it will break. But if you have a safety factor of 2, then it would be 601 pounds would make that chair break. Every industry uses a different safety factor. Some industries use a lower safety factor, and they're able to get away with it, so to speak, by having increased inspection or more often inspections. But safety factor in general is the way to go, and Fusion 360 will ask you for a safety factor as you're putting in the inputs for those load cases. So I hope that answers your question.
Awesome, thank you. Next question. How are intellectual property concerns protected given Xometry is a marketplace?
Oh yeah, absolutely. And you know, we take IP and information security very, very seriously at Xometry. If not, we wouldn't be in business. But we are using, when you upload your files, we are using the most secure cloud-based server. It's Amazon GovCloud. So it's the same, you know, same thing that you see a lot of, I would say, more sensitive file types go through in the US government as well. Your files are actually almost scrubbed, if you will, of information, including PMI right now for that, and they're given unique part identification. But we are essentially getting enough information for the successful manufacturer of that product. The transfer of the information is actually through Xometry's backend. So what you see when you get your instant quote is a very different experience than what our suppliers see, but our suppliers are also working through Xometry for the secure review of those files, the scope of the work, the acceptance of work, as well as the tracking the work and even the auditability factors. You know, for example, inspection reports, photos of the part. That information is actually stored you know, stored up within Xometry as well. That actually helps on our quality assurance side. But we have a lot of security measures in place, as well as our marketplace is not just, you know, any old shop. Every single shop that is part of Xometry's job board, who's actually able to review work, has gone through NDAs, other agreements with Xometry, and they've been vetted. So we actually have tests and we work through, depending on what process the manufacturers do, different levels of vetting that help us make sure that the suppliers that are producing parts on our network are the best suppliers. They are actually able to produce those jobs to scope and on time and are professionals in their service.
Awesome, thank
It's
you.
a mouthful. Yeah. Also, I have some, if you go to Xometry's FAQ, you can read a little bit more on that as well, but I'm always happy to speak more on that subject.
Great. Next question. Does Xometry have any 3D printers in-house, or is the manufacturing / 3D printing done to by sub-suppliers?
Both. So the answer is both. We have some technologies that we do run in-house. In fact, we have quite a nice additive manufacturing factory that runs particularly selective laser sintering as well as use position modeling Fortis machines. It's an army of machines, if you will, and we do some other polymer style or polyjet manufacturing there. But the vast majority of our work is through vetted partners, and these partners are best in class at what they do, whether they're a DMLS shop, whether they're a metal binder jetting shop, whether they're running HP multi-jet fusion or stereolithography, best in class suppliers. And what that really does is it helps make sure, like I said, that sweet spot manufacturing, we pair that work with those who perform it best. And that's what our goal at Xometry.
And Greg, I was going to comment that I think the most important thing is that you're putting the work at the right places so that your customers don't have to worry about that. All they have to worry about is the price going to work for them, and is the lead time going to work for them? And if so, they can place the order with Xometry. You'll deal with the back end work on who's actually going to manufacture it and who's going to ship it and get that to the customer on time.
Yeah, we make that automatic. It's almost like ordering from Amazon, right? You just kind of, it says it'll arrive at your door next Tuesday and you get your parts next Tuesday. It's the same thing, but we work with these vetted suppliers day in, day out, have really great relationships, and ultimately Xometry is responsible for the quality of the product. So anything that comes through, if there is an NCMR or RMA, that'll go to Xometry and we'll handle and make it right for you.
Awesome, thank you. Where does the Xometry plugin for Fusion 360 come from? Is it part of the latest version of the app, or must it be downloaded and installed?
So I was going to say, you're watching this live because in like 1 or 2 days. So right now, if you could, and you can still go to go through. If you go to Xometry, either Xometry.com and go to our resources page, you'll see other tools, CAD add-ins, and you could download that app. You can follow through and download the app for Fusion 360, both for Windows and Mac versions. It'll essentially take you to Fusion 360's App Store. So also the same way, if you go to Fusion 360's App Store, search for Xometry, you'll find that. I believe there will be an announcement when the 2.0, what Jason just previewed today, because it's gonna happen anytime now. It's in review. It's like it's in the store, but it's gonna show up sooner or later. That you should get an announcement for that, and you'll just download the new MSI file, double click and run, and it'll install over.
Awesome, thank you. And we have time for one more question. Is there an iterative process between DFM, generative design, and structural checks, i.e. stress/strain, FEA, etc.?
So generative design is actually doing all of that in the background. That's the whole point of it. If you run a standard finite element analysis, you take the results, and based on the results, you decide to change your design, you're going to find yourself in that loop over and over and over again. It might be 10 times, it might be 20 times, it might be 30 times. The end result is a product that might be better than you started, but you don't know if it's optimal. What generative design is doing in the background is running a finite element analysis, and based on the stress and strain on those particular nodes, so to speak, on your part, it's going to decide if it needs to add or subtract material. And when it does add or subtract material, it's keeping the manufacturing in mind. So it's not creating undercuts, so to speak, when it shouldn't. Then it goes back and runs another finite element analysis. And it will do that over and over and over again automatically until it converges on your safety factor. So if you have a safety factor goal of 1, it'll keep doing those iterations until it converges onto your safety factor, if it can reach that. And then it will tell you that you have a final result ready for your review. The whole point of generative design is taking that iterative process that you described and making it automatic for you. I hope that answers your question.
I gotta follow up on behalf of the customer, because I understand it. I think also it's like, now that you know that generative does it, how do you prove it out? Like, so would I just go and treat it like a regular FEA afterwards if I need to actually show like the heat map, for example, or the output, or is that part of the output with the generative process?
Oh, now I get it. I might have misunderstood that
How do I
question.
prove to my boss that it's right? That's
Right. So once you have a result that you're happy with, you can download it back into Fusion 360, and it'll automatically create for you a standard simulation for you to do your final checks.
awesome.
So if you wanted to run a static stress analysis or a nonlinear static stress analysis, even a dynamic analysis or vibration analysis, we make that really easy by taking those results and setting up that new analysis for you automatically. If you're using other software like ANSYS, for example, Autodesk has a partnership not only with Xometry, we also have a partnership with ANSYS, and there is a button from inside the simulation workspace of Fusion 360 that'll export your study to ANSYS Mechanical for further analysis. And it will take not only the geometry itself, it'll also bring the boundary conditions and the loads and the load cases, so that all you have to do is actually run this in ANSYS. But in summary, you get to choose if you'd like to run that in Fusion 360 using our cloud and stay within that one platform, or if you'd like to use other tools such as ANSYS, it's entirely your choice. But we make it easy.
That's great.
Great. Well, that concludes our webinar for today. Thank you again, Jason and Greg, and thank you attendees for joining us. We hope to see you all again for future webinars. Bye for now.
Thanks so much.
Thank you so much. Have a great day.